Welcome to Brain Vision.
Because lead-2 fluoride separates into one ion of lead-2 plus and two ions of fluoride, then the KSP expression is going to be equal to the concentration of Pb2 plus multiplied by the concentration of fluoride squared. If there's no other source of lead-2 plus and no other source of fluoride, then we can say the molar solubility will be equal to the lead-2 plus concentration, because every mole of the solid that dissolves in a liter will give us 1 mole of lead-2 plus in a liter. But the fluoride concentration, because we get 2 of them for every one of the compound, will be equal to 2S. So now we can go back to our KSP expression, the numerical value being equal to 3.3 times 10 to the negative 8, and plug in these expressions. We get S multiplied by 2S squared being equal to 3.3 times 10 to the negative 8. So S is going to be equal to the cube root of 3.3 times 10 to the negative 8 divided by 2 squared, which is 4. So the molar solubility is going to be 2.02 times 10 to the negative 3 molar. But remember, the molar solubility is the lead concentration, so that'll also be 2.02 times 10 to the negative 3 molar. Now for student B, the concentration of fluoride in tap water is 1.0 milligrams per liter. We can convert that fluoride concentration into moles per liter by recognizing that there are 1,000 milligrams in 1 gram, and then the molar mass of fluoride is 18.998. So 18.998 grams gives us 1 mole. This will then give us moles fluoride per liter. Or 5.26 times 10 to the negative 5 molar. Now knowing this, to solve for the lead concentration, we just plug in our fluoride. Forgot to square that up here. We plug in our fluoride and we solve for lead. So the lead concentration is going to be equal to 3.3 times 10 to the negative 8 divided by the fluoride concentration, 5.26 times 10 to the negative 5 molar squared. And we end up with some ridiculous value that doesn't even make any sense, 11.9 molar. And that's because this concentration is so low, it's essentially doing nothing to the concentration of fluoride that is created from just the equilibrium itself, which is going to be 2 times this value here. So it turns out that this calculation is irrelevant, and the lead concentration is again 2.02 times 10 to the negative 3. Then the final student adds some lead-2 nitrate crystals, and you're asked to calculate the concentration of lead in this case. Well, some lead will be created. This amount will be created from the equilibrium in pure water, but we'll get significantly more lead just coming from the lead-2 nitrate. So if we take 0.25 grams lead-2 nitrate But what volume? Yeah, a 1 liter. So we have 0.25 grams lead-2 nitrate. We convert that to moles. 331.2 grams for every 1 mole. And then we divide that by 1 liter. So 0.25, 331.2, divide, and we get 7.5, so 55 times 10 to the negative 4 molar. So actually it looks like this concentration is also less than this concentration here. So we're going to get most of the lead still coming from the dissociation of the lead-2 fluoride in a saturated solution of lead-2 fluoride. So we might end up with just a little bit more here, so we might get 2.8 times 10 to the negative 3 molar when we have a little bit of lead in there already.